In this video, I am going to discuss about soldering process, brazing process and adhesive bonding process. Joining processes are classified into three types: autogeneous joining process, homogeneous joining process and heterogeneous joining process. In autogeneous joining process, filler material are not used. Resistance welding is an example for autogeneous joining process. In homogeneous joining process, filler material are same material as base metal. Gas welding process are example for homogeneous joining process. In heterogeneous joining process, filler material is differ from base material. Filler material and base material are different. Soldering is an example for heterogeneous joining process. Soldering is the process by which metals are joined with the help of another alloy called solder without heating the base metal to be joined. So soldering is a process in which the metals are joined with the help of another alloy called solder, and during soldering process the base metal is not heated or melted. The melting point of the solder is always lower than the base material to be joined. During soldering process, the solder that acts as the filler material which melt and flow into the gap of the metals to be joined due to capillary action. The main principle of soldering process is capillary action, and after solidifying, a strong joint will be produced between the metal parts. See, this is the figure of a soldering process. Soldering process consists of soldering iron. The purpose of soldering iron is to produce heat which is used for melting solder. And this is the board, and this is a component which is used to fit in the some electrical board. So during soldering process, what will be happen? The soldering iron which will produce heat, due to that heat solder will melt, and that melted solder which will flow to the gap between the parts to be jointed due to capillary action, and after solidification a strong joint will be produced. Soldering can be classified into two types: soft soldering and hard soldering. So this is a two classification of soldering process: soft soldering and hard soldering. Hard soldering is again classified into brazing and silver brazing process. So this is a classification of the soldering process. So soldering process, it is classified into soft soldering and hard soldering. Hard soldering, that is again classified into brazing and silver brazing process. See, the process of joining metals using tin and lead as soldering alloy which melt below 420 degrees Celsius is known as soldering. So what you mean by soldering means the process of joining metals using tin and lead as soldering alloy. In a soldering process, tin and lead is used as the filler material. Tin have melting point of 327 degrees Celsius and lead have melting point of 232 degrees Celsius. So tin having a melting point of 327 degrees Celsius and lead having melting point of 232 degrees Celsius. So both of them which melt below 420 degrees Celsius. So in a soldering process, the filler material that melt below 420 degrees Celsius. Okay. Then the process of joining metals using copper, zinc and alloy as filler material, in which the filler metal is heated above 420 degrees Celsius below 850 degrees Celsius, called brazing. So second one is the brazing process. In brazing process, the filler material is using as copper, zinc or alloys, in which the filler metal is heated above 420 degrees Celsius below 850 degrees Celsius. Okay, the temperature is very important. So in a brazing process, the filler material used is copper and zinc, which having a melting point between 420 degrees Celsius and 850 degrees Celsius. Silver brazing is similar to brazing except that filler material is used is silver copper alloy and the flux is also different. So in a silver brazing process, the filler material is used is silver copper alloy. That is a filler material which is used for silver brazing process. Okay. See, in soldering process, commonly flux are used. What's the main purpose of a flux is deoxidization. Most commonly using flux in soldering process are zinc chloride, hydrochloric acid, ammonium chloride. These are the three type of flux which is used in a soldering process. So what is the use of flux in a soldering process is which is used for deoxidization, and commonly using flux are zinc chloride, hydrochloric acid and ammonium chloride. Soldering methods. There are 7 types of soldering method. Sorry. There are 9 types of soldering methods. So first one, soldering iron method. Second one, torch method. Third one, dip and wave method. Fourth one, induction method. Fifth one, resistance method. Sixth one, furnace and hot plate method. Seventh one, spray method. Eighth one, ultrasonic method. Ninth one, condensation method. So these are the different methods of soldering. So we can discuss important soldering methods only, not discussing the entire methods. So first one, soldering iron method. This is the traditional method. Soldering iron has a copper tip which may be heated electrically, commonly electrically. Tip of soldering iron conduct heat from the heat source to the component being jointed. See, soldering iron method is one of the traditional method of soldering which consists of soldering iron which have a copper tip. The purpose of soldering iron is to produce the heat required for soldering process. So this is the filler material that is solder. The soldering iron that will transfer heat to the solder filler material which melt and flow to the gap between the parts to be jointed due to capillary action. Next method is dip method. Dip and wave method. Dip soldering consists of dipping the assembled flux coated joint into a pool of molten solder. Dip soldering is used for mass production of joints. So in dip soldering, the entire assembly, flux coated assembly is dipping in a molten solder and the joining will happen. This is commonly used for mass production of joints. In wave soldering, the parts to be soldered are carried by a conveyor. Parts to be soldered touches a wave of solder pumped from solder bath through a narrow slot. See, in a wave soldering method, the parts to be soldered are placed over a conveyor belt and it will be slowly moving. And the flux that will be spraying over the parts through a narrow slot to the component or the metal parts to be jointed. See, this is the flux that will be pumping or spraying over the parts that will be slowly moving through a conveyor belt. Okay, so that is known as dip wave soldering method. Next one is torch soldering method. In torch soldering, a gas torch is used to supply heat which may have single or multiple orifice tip. Torch soldering is used when parts are too large for soldering iron. Torch may operate on air, acetylene, oxygen and acetylene, etc. So torch soldering method which is used if the parts will be very large and soldering iron that cannot produce much amount of heat required for joining. See, in torch soldering, a gas torch that is used for supplying heat. Commonly air acetylene or oxyacetylene torch are used. Okay, so that's about soldering process. Next one is brazing process. Brazing is a metal joining process in which is done at a temperature of above 450 degrees Celsius. That's very important. Brazing is a metal joining process which is done at a temperature of above 450 degrees Celsius. Brazing filler rod melt at a temperature of from 860 degrees Celsius to 950 degrees Celsius and are used to braze iron and its alloys. Brazing is employed where a ductile joint is required. So these are the important points regarding brazing. So brazing, the filler material melt above 450 degrees Celsius. That means between 860 to 950 degrees Celsius. And brazing processes are commonly used for producing ductile joints. Next one, various method of brazing. There are four methods of brazing. First one, torch brazing. Second one, furnace brazing. Third one, dip brazing. And fourth one, induction brazing. So these are the four methods of brazing process. So first one, torch brazing. Base metal is heated to the required temperature by the application of oxyacetylene flame. See, in a torch brazing process, this is the filler metal and these are the components to be joined and this is the torch. So a gas torch that is used for producing, supplying heat during brazing process, that is known as torch brazing process. Oxyacetylene flame are commonly used for torch brazing process. Next one, furnace brazing process. The parts to be brazed are aligned with the brazing material placed in the joint. The assembly is kept in a furnace. So in the furnace brazing process, commonly used for mass production. So parts to be joined are aligned with the brazing material and placed in the joint, and the entire assembly is placed inside the furnace for heating. So during heating, the filler material melt and the joint is formed. And dip brazing. The parts to be brazed are submerged in a molten metal or a chemical bath. As dip soldering, in dip brazing also, the parts to be joined are completely dipped in a molten bath or chemical bath. This is also used for mass production process. Next one, last one is induction brazing process. See, in an induction brazing process, parts to be brazed are heated to the melting point of the brazing material by means of a high frequency electric current. See, in induction brazing process, the brazing material or filler material is heated by using a high frequency electric current. This is done by encircling the joint with a water cooled induction coil. See, this is the water cooled induction coil which is used to provide the heat to the heat for producing the joint. So this is the filler material. So when the heat is produced, the filler material melt and joint is formed. So this is about the brazing process. Okay. The last one is the advantages of brazing process. There is no flash or weld spatter. Brazing technique does not require much skill. The process can be easily mechanized. Disadvantages are all brazing alloy lose strength at elevated temperature. Color of brazing alloy is not matched with the base metal. So these are the advantages and disadvantages of brazing process. So third one is the adhesive bonding. See, adhesive bonding are made by putting a thin film of liquid or semi-solid adhesive between the parts and immobilizing the assembly until it solidifies. So what is adhesive bonding? എന്താണ് adhesive bonding? രണ്ട് പാർട്സ് തമ്മിൽ അഡ്ഹസീവ് ബോണ്ടിങ് ചെയ്യണമെങ്കിൽ ജോയിനിങ് ചെയ്യണമെങ്കിൽ സെമി സോൾഡ് ആയിട്ടുള്ള അഡ്ഹസീവ് അതിനിടയിൽ വെച്ചതിന് ശേഷം പാർട്സിനെ മൂവ്മെന്റ് ഇല്ലാതെ ഇമ്മൊബിലൈസ് ചെയ്താതെ വെക്കുക. Then it will be get solidified and bond will be produced. That is known as adhesive bond. Adhesive may be in the solid or molten state or in a liquid form. Adhesive bonding technology offers great design flexibility as it can be easily integrated into almost all available industrial sequence of single piece workpiece or mass production. So in the case of adhesive bonding, the semi-solid adhesive is pasting between the parts to be jointed, and the part is kept in immobilizing for a certain time period, and the adhesive gets solidified and a bond is produced. That is known as adhesive bonding. Types of adhesive used in adhesive bonding: polymer, polyimide, polyurethane melt adhesive, toughened acrylic, silicon adhesive, epoxy adhesive. So these are the types of adhesive which is used in the adhesive bonding process. So in this class, I have discussed about soldering process, types of soldering process, brazing process, types of brazing process, adhesive bonding, and types of adhesive that is used for adhesive bonding process. Thank you.